Friday Math Happy Hour. Today's topics, we're going to cover the exam review number 2, which covers sections from chapter 4 and chapter 5. So I'm going to do maybe 1 or 2 problems from each section, and hopefully this will be helpful for your exam review. Okay, the first thing that we're going to cover is the section 4.1, which are called graphing exponential functions. So number 1, graph f of x equals to 2 to the power of x. Okay, so we're going to evaluate the function at x equals -2, -1, 0, 1, 2, and 3. When you're trying to graph exponential functions, these are the x values that are recommended, like from -2 all the way to 3. Okay, so these are the values that we're going to evaluate it from. So to start off, let's draw ourselves a table. Okay. So when x equals -2, right, we're going to go here to the function on the right, and we're going to evaluate it at -2. So it's going to be 2 to the -2nd power, which is equal to 1 over 2 to the 4th power, which is equal to 1/4. If you have a calculator, you can actually plug it in here, 2 to the power -2, and it's going to give you 1/4. But I'm trying to show you also to do it without a calculator. Okay. So when x is -2, f of x, which is y, is 1/4. Now let's try when x is -1. So we're going to evaluate the function at x equals -1. So it's going to be 2 to the -1 power. So we apply the negative exponent rule, which would be 1 to the 2 to the 1st power, which is equal to 1/2. So when x is -1, y is 1/2. Now let's continue with when x is 0. When x is 0, again, we'll repeat the process. We're going to evaluate the function at f of 0, which means I'm going to plug in 0 where the x is on the function. So any number to the 0 power is always equal to 1. So when x is 0, y is 1. Now let's try when x equals to 1. Again, we're going to evaluate the function at 1. So it's going to be 2 to the 1st power, which is equal to 2. So when x is 1, y is 2. Let's continue evaluated at x equals 2. So f of 2 will give us 4. So when x is 2, y is 4. And lastly, when x equals to 3, we evaluate the function f of 3, which means, again, we're going to plug in the 3 where the x is, and we get 8, because 2 to the 3rd power is 2 times 2 times 2. Please do not make the mistake, which I've seen a lot of students make. They state that 2 to the 3rd power equals 6, because they tend to multiply the exponent times the base, which is not correct. Again, I repeat, 2 to the 3rd power is the equivalent to 2 times 2 times 2, which is 8. So when x is 3, y is 8. So we got our point. So now, right, so now we're going to graph it, right? So for example, it's already graphed there, guys, but for example, when x equals -2, right, y is 1/4, so it'll be about right there. Then when x is -1, let's go here to the -1 on the number line. I mean on the polar coordinate graph. So when x equals -1, y is 1/2. And as you continue and we plot all these points, this will be my graph. That's why we don't want to plug in something more than 3, because if we have 2 to the 4th power, it's going to give me 16. So 16 will be out of the range over here. That's why the wise choices to choose for x are usually from -2 to about 2 or 3. Okay. Now let's see what happens when we graph f of x equals to the power of x minus 1. So again, let's do a little table. So again, we're going to pick almost the similar values, but here we go all the way to 4, because 4 minus 1 will give us 3. So anyway, when x is -2, we're going to plug in -2 where the x is, which will give us 2 to the -3rd power, which will give us 1 over 2 cubed, which will be 1 over 8. So when x is -2, y is 1 over 8. And when x is -1, again, right, we keep repeating the process. We're going to plug in -1 for the x's. So -1 minus 1 will give us -2. And 2 to the negative second power will be 1 over 1 over 2 to the second power, which will be 1/4. So when x is -1, f of x or y is equal to 1/4. And if we keep, as we keep repeating the process, right, we're going to get 1/2. When x is 1, right, we're going to get 1. When x is 2, right, we repeat the process, so it's going to give us 2. And when x is 3, again, we evaluated at f of 3, we're going to plug in 3 for the x's, so it's going to be 2 squared, which is equal to 4. And when x is equal to 4, it's going to give us 2 to the third power, which is equal to 8. So this graph will look something, you know what, let me go back real quick. Previous and previous. You know what, I didn't put the graph there, but let me show you how it looks like, okay? So this graph is going to go, everything's going to move 1 unit to the right, okay? So for example, this graph, it will be the same graph, but everything moves 1 unit to the right. As you notice, over here, right, when it was -2, it was 1/8. Now, when it's -2, it's going to be 1/4. So everything moves, I repeat, every point on the x-axis moves 1 unit to the right, okay? It's like the same thing as this is a parent function, right? And before, when you have x minus, right, it's going to move the opposite way, horizontal shift to the right 1 unit. I just forgot to put a graph there, guys, okay? And I'm sorry about that. Okay, so let's continue. Now this graph, g of x equals 2 to a negative x, right? So we simplify it. So it's the same thing as graphing 1/2 to the x power. 2 to a negative x is the same thing as 1/2 to the x power. And again, as we plug in all the values, right, when it's -3, it's going to give us, right, we do the reciprocal, it's going to be 2 over 1, and it becomes positive, so it's going to be 8. And when you see it's 8, so then when we plug in, the -2, the -1, 0, 1, 2, and 3, right, and we repeat the process, these will be the values here on the right. Okay, now, so to graph it, right, so when it's -3, it'll be -1, -2, -3, it's going to give us 8. When it's -2, right, it's going to give us 4. When it's 0, right, it's going to give us 1. And as you notice, f is 1 is going to be 1/2. When x is 2, it's going to give us 1/4. And when it's 3, it's going to give us 1/8. That's why we don't want to pick no more values for x that is 4, because eventually it's going to get, this graph here is going to get closer and closer and closer to the x-axis, but it will never reach it, okay? So this is a graph. This is called exponential decay, because it starts high and it goes low, okay? Okay, now, how do you apply it like in real life? Okay, so here they're going to give you a word problem. This is number 4. It says the assets in billions of dollars for a prudential financial incorporation can be approximated by the function a of x equals to 315e to the 0.056x, where x equals 7 corresponds to the year 2007. Find the assets for the following years. So since x equals 7, right, corresponds to the year 2007, that's what it says here, right, on the problem. So then when x is 0 corresponds to the year 2000, and when x is 12 corresponds to the year 2012. So what we do, we're going to plug in to evaluate it at a of 0, right, because it's the year 2000, we're going to plug in 0 for the x's. And I repeat, remember before, so 0.056 times 0 will give us 0. Anything to a 0 power will give us 1, right? So that will give us 1. So 315 times 1 will give us 315. But remember, the assets are in billions of dollars. So this will be equal to $315 billion. Now, okay, so now this is good to know. 315 is the initial value, because when time is equal to 0, right, no time has passed, this will always be, this is called your initial value. Okay, please remember that. Because here in the year 2000, no time has passed. So that means that the 315 will be the initial value. And it's good to know that because when you try to solve other word problems, it's crucial that this will be the initial value, which I'm going to explain, I believe, in the next slide. So now let's try B. So we're going to evaluate at A of 12, which means I'm going to plug in 12 for the x is. Okay. And again, make sure that in your calculator, right, you put it in parentheses, because if not, at times when students don't do that, and they want to put it like 315e to the 0.056 times 12 without parentheses, at times the calculator will follow PEMDAS, which is order of operations. They'll multiply 315 times e to the 0.056, and they multiply that by 12, which is not correct. That's why make sure that that the 0.056 times 12 is in parentheses. So then this is your value, 616.817157. Okay, which approximates, say, to the nearest tenth. So it'll be 616.8, but remember, it's in billions of dollars. So the answer will be $616.8 billion. Okay, now, this is number 5. It says here, a deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown to 128. I eventually got this problem, guys. We kind of made it up there on, right before COVID, and kind of altered the way classes were held. And I believe we're about to do this section right before spring break. And that used the data that was given, right, from the news. And then we came out with this problem here, just so students will know what exponential functions can do if they're not contained. Okay, so this is like a case, right? Say there was no intervention, then there's going to be a lot of people infected. So this is a problem that we can relate to. And again, okay, let me read it from the beginning. A deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases have grown to 128. And I believe I got this data from the news, because I believe toward the end of January, there were 2 people that were infected, I believe, in Washington. So I use a scenario to come up with a formula just to show the students how math is related to the real world. Okay? So for part A, it says find the model of the form f of t equals to y naught b to the t, where t equals 0 corresponds to the end of the month of January. And B, if the trend continues, how many people will be infected by the end of the year? Okay, so let's find out. So solution, need to find y naught and b. Y naught, guys, is the initial value, okay? Y naught is the amount present at time equals to 0. So since t equals 0 corresponds to the end of January, then y naught equals 2, right? This is my initial value because before any time has started, there were 2 cases. So that's why the y naught is equal to 2. When t equals 1, right, corresponds to the end of February, right? Because if it started at the end of January, so one month later, which would be the end of February, t equals 1. And t equals 2 corresponds to the end of March. And t equals 3 corresponds to the end of April, right? Because it's saying that there were 2 cases by the end of April. The cases had grown to 128. So in April, there were 128. Okay, so let's use that information to find the model. So here, guys, I just did here like t equals 1 corresponds to the end of February, but if you knew, you can go from t equals 0 all the way to t equals 3 corresponds to the end of April. But I showed every step. Now students will have a better understanding. Okay, so this is my information. I know that the y naught equals to 2, right? So I already found y naught. Now I need to find b. So, right, so here, 3 months, this means like this, 3 months later, right? F of 3 means 3 months later, we had 128, and I got that info from here when t equals 3 corresponds to the end of April, there were 128 cases. And y naught equals 2. So I'm going to plug in the y naught, here in the formula, right, for the 2. The 128 is going to be the amount in 3 months. That's why 128 equals to 2, b to the third, right, because t equals to 3. So from here, we're going to try to solve for b. So the first part that we do is we divide both sides by 2, right, which will give us 64 equals to b to the third power. Now here, you can take the cube root of both sides, or else raise it to the 1/3 power. Okay. because here on the right, b to the third power raised to the 1/3 power, right? We use the power exponent rule. When you have a power raised to a power, you multiply the powers. So this will be 3/3, which is equal to 1, right? So the b will be isolated. And 64 to the 1/3 power will give us 4. So I found my a, which is 2, and I found my b, which is 4. Now let's plug it into the formula. Okay. Now this is the answer for a. For a part, they want us to find the model, so we did. Now for b part, right? For b part, it's saying if the trend continues, of how many people will be infected by the end of the year. So we know it's going to be to December. It's going to be 11 months. How do we know that? Because if 3 equals 3 corresponds to April, if you keep going, like 4 will be May, 5 will be June, 6 will be July, and so forth. When you get to the end of December, it's going to be 11. So that's why we evaluate the function at f of 11, which means after 11 months, this is the amount of people that will be infected. So like 8,288,600 people will be infected by the end of the year. This was not the case, right? Because what happened, this was for the US. But what happened here, guys, there was a lot of interventions. For example, countries began to isolate their countries, right? Quarantines and stuff. But this will be the actual amount of people infected, and there was no intervention. For example, if nothing if nobody did nothing, the people will keep getting infected, and this will be the approximation of how many people will be infected. Okay. But thank God for intervention that we use masks and all that stuff. Okay, now we're going to be doing solving exponential equations. Okay, so this is a rule that we're going to be using. It says let a be a positive real number with a cannot equal to 1. Okay, now here it is. If a to the u equals to a to the b, right? That means you have the same base, right? This is called a base. Then the exponent must equal to each other. That's what the rule indicates. So for example, here, right, we have 3 and 3, right? We have the same base. So then the rule can be applied. So x must equal to 5. Now this is number 6. If you notice, 125 and 5 are not the same base, right? So we have to make, get the same bases on both sides of the equal sign. So we know that 125 equals to 5 cubed, right? So then we know if we plug in 5 cubed for 125, right, then we're going to have the same base. Now here we're going to apply the power rule, exponent power rule, which means when you have a power to a power, we multiply the powers, which will give us 5 to the 3x equals to 5 to the 5th power. Now we got the same base. So now we can apply the rule. So when you have the same base, we let the exponents equal to each other. So 3x equals to 5. We divide both sides by 3. So the answer will be 5/3. And you can always check your work, right? So for example, if we know that x equals to 5/3, we can plug it in where the x is, and it's going to, it has to give us 5 to the 5th power. Okay? You plug into the calculator. So they both give us 3,125 for both sides, which we know this is the correct answer. The beauty about exponential functions and logarithmic functions is that you can always check your work. Well, same as other equations, but I like to check my work here. And I tell my students the importance of checking your work. Okay. Solving exponential equations continue. Now let's try this one. Are they the same base? No, they're not. Not the same base, right? So we have to make them both the same base. Let's first start. If 4 is a base of 32, right? So if we put 4 squared equals to 16, not 32. Let's try 4 to the 3rd power. It gives us 64, right? So we passed the 32 here, guys. So that means that we have to find the common base between 4 and 32. Now we know that 4 is equal to 2 squared. And we also should know that 32 equals to 2 to the 5th power. Let's pretend that you didn't know that you don't know that 32 equals to 2 to the 5th power. How can we find that out? So this is what I tell my students. You go in the calculator, right? So we know that 4 equals to 2 squared. So we're going to try to find the common basis of 2. So what you do is just put 2 to the 3rd power, 2 to the 4th power, 2 to the 5th power, and so forth until you find a match. And sure enough, when you get 2 to the 5th power, it gave us a match, right? Because 32 equals to 2 to the 5th power. So now I found the common basis between 4 and 32. So I'm going to plug in 2 squared where the 4 is and bring down the exponent, which is x minus 1. And I'm going to substitute 2 to the 5th power for the 32. Then here on the left side, I apply the exponent power rule, which means when you have a power to a power, you multiply the powers. Okay. Now we got the same base. So now the rule can be applied. So we let the exponents equal to each other, and we solve for x. Right here, we're going to distribute. And then here, we're going to add 2 to both sides. And next step, we're going to divide by 2. So the answer will be 7 over 2. And again, we can always check our work. And we put 7 over 2 where the x is. It's going to give us what? 4 to the 5 halves power. And if you put that in the calculator, 4 to the 5 halves power is going to give us 32. So we know that the answer is correct. So x equals 7 over 2. Okay, now, the next topic that we're going to cover is writing exponential equations into logarithmic equations and vice versa. So definition of logarithms to the base a. This is logarithmic form, y equals to log base a x, which means this is exponential form, a to the y equals x. So this is on the left is logarithmic form, and on the right is exponential form. For example, number 8, write each logarithmic equation into an exponential equation. So I always tell my students that you have to find the y, you have to find the a, you have to find the x. Okay. So here, right, a is going to be my 9, my x is going to be my 81, and my y will be 2. Now all we do is going to plug it in here, so it's going to be 9 to the 2nd power equals 81. And again, there's my a, there's my y, and there's my x. So now, number 9, write each exponential equation into a logarithmic equation. Now they're going the other way, right? So instead of going from a logarithmic to exponential, now you're going to go from exponential to logarithmic. And again, you use the same property here. So we have a to the y equals x. This is exponential form, and on the right is logarithmic form. Y equals to
Hi, Mr. Z. Sorry to interrupt, but Antonio has a question for you.
Okay,
He wants to.
that's okay, Patricia, that's okay. Yes, Antonio.
He's asking if this is for test 3.
No, this is for test 2. All this information
Okay, thank
is
you.
for test number 2. What was that it, Patricia?
Yes, sir.
Okay. Okay, I believe Antonio, test 3 comes in about 4 weeks, my friend. Okay, but this is for test 2. Well, anyway, thank you for your question. Okay, thank you, Patricia, Antonio. Okay, now again, this is number 9. So we have a to the y equals, right? So we have to go from exponential to logarithmic. So again, we have to know what the a, what the y, and what the x is. My a is going to be 5. My y is 3, right? My y is 3, and my x is 125. So now we go back here to the exponential, from exponential to logarithmic. So we know that y is 3, right? My base, which is 8, is 5, and my x is 125. Or you can write the other way. Log base 5, 125 equals 3. So this is the same thing, because at times students ask me, hey, Mr. Isasi, in back of the book, it's not in this form, it's in this form. It's the same thing, right? Because if you switch, the 3 from the left side to the right side, and the log base 5 or 125 on the right side to the left side, it's still the same thing. So these are equivalent. Okay. Okay, now number 10, we're going to be graphing logarithmic functions. Okay, now in order to graph without a calculator, you must convert logarithmic equations into an exponential equation. Okay, by using the same properties of what we just used. So the equation is going to be in logarithmic form. But to graph it, you have to, to graph it by hand, you have to convert it to exponential form. So it's going to go from y equals to log base ax is equal to a to the y power equals x. Okay, example number 10. Graph y equals to log of base 2 of x. So by using the properties from before, right, we know it's going to be a to the y equals x. So my a is going to be 2. We keep the y how it is, and we keep the x how it is. Right, so now we're going to do a table. But instead of plugging in the values for the x, we're going to plug them in for y, because the work will be much more easier. If you plug it in for x, the work is tedious, and you have to know a lot of more properties. How to bring down the exponent down, which requires a lot of more work. So the smart way to do is to plug them in on the exponent, which is a y. Okay, so then what we do, right, so if we plug in -2 for the y, it's going to give us, right, y x equals to 2 to a -2 will be 1 over 2 squared, which will be 1/4. So when y is -2, x is 1/4, and if you keep repeating the process, right, these will be my values for the x. Okay. You put 0, it's going to be 1. If you plug in 1, it's going to be 2. If you plug in 2 into the y here, it's going to give us 4. And lastly, if you plug in 3 where the y is, going to give us 8. So this is the way the graph looks. If you notice, this was an exponential function, right? But the log is this one here on the red. This was the one that we graphed earlier, I believe, y equals to 2 to the x power. And the one in red is a graph for the log function of log of base 2 of x. So why am I showing you these two? Because these are called inverse of each other. Okay? Because if you draw like a line on the y equals to x axis here, right? On the y equals to x axis, all these points will come over here. In other words, I believe when we graph y equals to 2x, right? All the x's were here, and then the y's were equal to the where the y is. So if you invert, say that, for example, if you put all these values for x, and then all these 6 values for y, is going to be the graph in blue. Okay, that's what it means, that they're inverse of each other. That all you do is switch the x and the y. Okay, and I repeat, if you change all the y values here for the x and the x values for the y, you get the graph in blue. Okay, because they're inverse of each other. It's always good to know extra information. But anyway, that's how you graph a logarithmic function, is by first converting it to an exponential function and plugging the values for y, not for x. Okay. Okay, now expand and condense logarithmic equations. So these are more properties that are crucial for this section. If you have, this is called condensed, this is called expanded. What I believe in the 1324 book, they call this in single log and expanded log. So if you have log of base a of x times y, you separate them by putting log of a of x plus log of a of y. So if it's multiplication, right, and it's condensed, you can expand it and put a positive, it will be addition. This is called the product property, the quotient property, and the power property. And if you're dividing, right, when it's condensed, then you expand it, and then if it's division, it's going to be subtraction. And for the power rule, right, if you have log of base a of x to the r goes to the front, as you have here on the right. Okay, so these properties are crucial. And in similar form, right, also the natural log, the ln steps for natural log. If you have the ln of xy, again, we do the same thing as what we did for the logs. When it's multiplication, the expanded form will be addition. When it's division, when it's condensed, the expanded form will be subtraction. And the same manner, right, when you have ln of x to the r power, the r goes to the front. Just the same as with the log properties. So now, it says here, write each expression as a sum or difference of logarithms with all variables to the first degree. Okay, now, you have log, of 5x to the fourth power, y to the third power. Like I tell my students, how many numbers of variables do we have here? We have 1, 2, 3. So it's going to give us 3 different logs. Okay, but for example, which properties are present? We have the product property, right? And also the power property. And again, we need to add 3 separate log terms because we have a coefficient and 2 variables. So for each coefficient and variable, it's going to be a separate log. We have log of 5 plus log of x to the fourth power plus log of y to the third power. That's applying the product property. Now we need to apply the exponent property, right, which is number 3 here, which the exponent, they all go to the front. See? And again, the 3 goes to the front. So this is that was my solution right there. Let me go back real quick. Something's wrong with my mouse. Okay, so you see, this is my solution. Okay, which is parentheses 5 times x to the fourth power times y to the third power, close parentheses, is equal to the log of 5 plus 4 log of x plus 3 log of y. If you notice, there's no base here, right? If there's no base, the base is 10. Okay, I repeat, when it's base 10, they don't put the base 10 there. They don't put a 10 there. They put a base when it's other base besides 10. I repeat, when there's no base, the base is 10. Okay, now again the same properties. But this time, right, we're going to use the quotient rule. This will be the quotient rule, product rule, and the power rule. Well, all 3 properties are going to be there. So first, all right. So first, what we do here, right, we're going to do the top first. So it's going to give us, right, so it's going to give us the log of x squared, xy squared, minus, because the minus, right, is going to be the quotient, log of w. Then we're going to apply the product, execute the product property on log of x, y squared, which means these, I'm going to separate them, right? I'm going to go from condensed to expanded only on the log of x times y to the second power. Okay. And then we bring down the minus log of w. Now we have to execute the power property, right? When the exponent goes to the front. The 2 goes to the front. And now this is how it's simplified. So we go from log of x times y squared divided by w is equal to log of x plus 2 log of y minus log of w. Okay, now we're going to go they're going to go the other way, I believe. So now you have to convert it to a single log. Okay, so again here, which properties are present? We have the quotient, right? We have the quotient because we have subtraction, the quotient, and we have the power property because we have a number in the front, which is a 2, that's going to be my exponent. So the power and the quotient properties are present. So first, right, execute the power property. The coefficient in front of the first term goes, so this goes as the exponent. Okay. Then you're going to execute the quotient property, right? Because we have subtraction over here on the right, we have subtraction, is going to be division. So this is my solution here. So this is how you simplify or write the expanded form in a single log. So it's going to be the ln parentheses x plus 7 to the second power divided by x plus 3. Okay, now solving logarithmic equations. Okay, to solve logarithmic and exponential equations, need to know previous properties such as, right? So these are properties that we need to know again, right? The product property, quotient property, and power property of the logs and natural logs. So for example, we have 6 to the x power equals to 72. So here we have to apply, right? So it's always used to use the natural log. In my opinion, this is easier because this one, the natural log leads to the next chapter, which is chapter 5, which is the finance chapter. So that's why I tell my students that I prefer for them to use the natural log. So I want to bring the x down, right? So I want to bring it down because you cannot solve for x as an exponent. So what do we do? Right, bring down the exponent by taking the ln on both sides. Because when you have the ln, right, here on the right, on the third property, the exponent goes to the front. So we're going to take the ln on both sides on the left of each side. Now by rule, the property rule, the exponent goes to the front, which is the x. Now we can divide both sides by the ln of 6. Please, guys, don't make the mistake. The ln of 6 is a number. It's together. Okay, you cannot divide by 6. That's a no-no, because the ln of 6 is together with the ln. It's a number. Okay, the ln of 6 actually has a value. So what do? We divide both sides by the ln of 6. Now you can put this in the calculator, and your answer will be approximately 2.386852807. But most of the times they want you to round off, I believe, to 4 places. So you're going to go, if it's 4 places, you're going to go all the way to the 5th place, right? So it's 1, 2, 3, 4, 5. So right, so for the 5 is the 5th place. But since you're running off to the 4th place, right? If this place here, which is the 5th place, if it's 5 or more, you add 1. Here to the 8, right? Since it's 5, you add 1 to the 8, which will give us 9. So this is approximately the answer. That's why those 2 little quiggly lines means approximately. Okay. And again, very important, the ln of a number is actually a value, cannot separate them, like I mentioned earlier. Now we're going to be solving a log equation. Solve log x equals to log of x plus 3 minus log of x minus 1. So before we log it, right? Before we solve this, they have to be in single log, right? Both sides in a single log. If we notice, the left side is okay, but the right side is not as a single log. So we have to make it a single log, right? So here is a quotient rule. So we're gonna write for the quotient rule from before, right? So we're gonna put it as single log. So this is gonna be division. So the first log, x plus 3 is on top. The x plus 3 will be your numerator. And the minus a log, the x minus 1 will be as your denominator. Now, right now you can apply the rule because you have the same log with the same base. A single log with the same base, which is base 10. So then, by applying the rule, x equals to x plus 3 over x minus 1. Now you can solve it here like two different ways. I believe you can use a cross property, or the cross multiply, which would be x times x minus 1 equals to x plus 3 times 1, because x, you can rewrite it as x over 1. Okay, or you can multiply both sides by x minus 1, and here on the right side, the x minus 1 will cancel if you multiply by x minus 1, and when you do to the right side, you also do to the left side. So you multiply x times x minus 1. This is my result. It will be x times x minus 1 equals to x plus 3. Now I'm going to distribute. So it'll be x squared minus x equals to x plus 3. Since we have a power of 2 right on the left side, we're going to solve the quadratic equation. So which means the x plus 3 must go to the left side. So we're going to do it by subtracting minus x and minus 3 to both sides. So we have x squared minus 2x minus 3 equals to 0. Now we're going to factor. So to factor is going to be x minus 3 and x plus 1 equals to 0. If you guys don't know how to factor, I believe I did a presentation in week 3 on factoring. So you can go back and look at the video to help you how to factor. And then we use I believe it's called the zero property theorem. When you have two binomials equal to 0, you let each one equals to 0, which would be x minus 3 equals 0, or x plus 1 equals to 0, and you solve for x. So on the left side is going to be x equals 3 and x equals to negative 1. So these are my solutions. But I repeat, you always check your work. Okay, so we're going to check our work. I believe I mentioned last week when I was doing this this PowerPoint or this presentation. I mean the presentation for that week, that the logs and the ln's cannot be negative, or they cannot be even be zero. They have to be more than zero. So in other words, right, for example, if we plug in here -1, right, you see it's going to give us error or something in the calculator. This is not defined, which means that x cannot equal to -1. So -1 is not a solution. Now, if you plug in 3, right, I'm going to plug in 3 for the x's on the left, and also on the right for the x plus 3. I'm going to plug in 3, and also 3 here to 3 minus 1. So 3 plus 3, right, is going to give us log of base 6 minus log of 2. Now, if you put that in the calculator, guys, right, it is going to be equal. But anyway, you can do it another way. You can do it without a calculator. If you notice, right, on the right-hand side, the left-hand side is okay because it's only log of 3. But the right side, you can apply the quotient property, right? When you have a quotient of log of 6 minus log of 2, right, you're going to condense it as a single log. And the first value on the log will be your numerator, and the second value on the log will be your denominator. So 6 divided by 2 is 3. So log of 3 equals to log of 3. So I know that 3 is a solution. Let's try solving logarithmic equations. Continue. Okay, now here is another property. If you have well, it says if a and u are positive real numbers with a cannot equal to 1, then the base a to the power of log of base a u equals to u. So in other words, when the base here for the exponent I mean for the base and the base of the log, right, are the same, then I mean whatever this value is for the u is, that's what the value is on the right. Example. Okay, I want to get rid of the log of base 4. So I'm going to raise both the left and the right side. This will be my exponent, right? So it's going to be big 4 on the left and a 4 on the right. So these are my bases now, right? Because it was a 4. If that was a 6, then it will be 6 on the left and 6 on the right, right? And you let, for example, it says here, you let the expressions on both sides of the equal sign be the exponents, and the base of the logarithm be your base, right? It says that's what it means here. So you're going to let both sides of the equal sign be your exponents, and whatever the base is, that'll be the base that you're going to apply on both sides. So this will cancel, right? I mean, according to the rule, 4 to the power of log of 4 is equal to 1. So we just bring down the 5x plus 6, and 4 squared is equal to 16. Right, simplify. Now we subtract 6 from both sides. So 5x equals 10. Now we divide both sides by 5. So x equals to 2. Now we can check our work, right? By plugging in 2 for the x's. Right, so 5 times 2 is 10. 10 plus 6 is 16. So log of 4 of 16 equals 2, because this is how you read I mean, this is how you read or simplify log of 4 to the 16th. You ask yourself, what exponent, I mean 4 to what power gives you 16? That's how you read it. Again, 4 to what power gives you 16? So the answer is 2. Or you can plug this in the calculator by using the change of base, and it's going to give us 2. So 2 equals to 2. So we know 2 is a solution. Hey guys, all those slides up to this point were from chapter 4. Now I'm going to do the next 4 problems will be from chapter 5. So this is 5.1. It's called simple interest. Okay, here's number 17. Gabriel invested his summer earnings of $3,000 in a savings account for college. The account pays 1.5% simple interest. What will be the value of the account after 2 years? And how much interest did he earn? Okay, so there's certain formulas for every section. For example, the formula for 5.1, there's 2 different formulas, but this is the one they're going to be using. Why do we know this is a 1? Because we're looking for the future value. Okay, so we're looking for the future value. So the amount that Gabriel invested was $3,000. So the PV stands for present value, which is $3,000. The R stands for the interest rate, and the key symbol that is the interest rate is where you see the percent symbol, which is 1.5%. But you have to convert it to a decimal. You can divide 1.5 by 100 or move the decimal place 2 places to the left, and you drop the symbol, which will be 0.015. And the time has to be in years, right? So here, it says here, what will be the value of the account after 2 years, right? So it's in years, so T equals 2. So all we do is plug into the formula, right? And just put it how it is in the calculator. So that's the solution, which is $3,090. Right? The answer will be $3,090, but to find the interest, how much interest did he earn? The interest earned is the future value minus the present value, so it'll be 3,090 minus 3,000, which is equal to 90. So the answer is, right, so the value of the account after 2 years will be 3,090, and the interest earned will be $90. So these are the two answers for number 17. Okay, now number 18. Number 18 is from section 5.2, and this is a compound interest formula. What's the difference between the 5.1 and 5.2? For 5.1, it's a simple interest, and 5.2 is compound interest. The only difference will be the M here, the M. That's the compound. That means compound. How many times it's compounded? But the formula on top is the same formula as the bottom. The only difference is that Rm is equal to the I, and the MT is equal to N, right? Just as I have here on the I, and the N over here at the bottom. So the AV stands for future or maturity value. The PV stands for the principal or the present value. The R stands for the interest rate per period. You convert it to a decimal. The M is the number of compounding periods per year. The T is the number of years. And the I is the interest rate per period, which is the R divided by M. And the N is the total number of compounded periods, which is the M times T. Okay? Now, these are key words for compound, right? If you see the word compounded yearly or annually, that means you're going to plug in 1 for the M. If you see the words, right, or if you read the words semi-annually or bi-yearly, M is equal to 2. If it's quarterly, M is equal to 4. If it's monthly, M is equal to 12. If it's weekly, M is equal to 52 because there's 52 weeks in a year. If it's daily, it's going to be 360 or 365. We know there's 365 days in a year, but at times the book wants you to use 360. If the book states to use 360, well, then you use 360, but if it doesn't state what to use, you stick with 365. Now, if it's continuous, right? If it says continuous, compounded continuous, it's a different formula, which would be if future value, FV equals to present value, e to the power of RT. Okay, now, and again, how do we use compound interest? Compound interest can be invested, right? Say that you have some money there at your house and you want to invest it. You can put it in a bank, right? The bank, and you don't deposit no extra money. And then you wait for a certain amount of time, and then on a certain amount of time, you're gonna have extra money that is called interest. That's how much interest you earn on the money that you deposit. Okay, so let's do an example. Okay, it says you deposit $9,000 in an account at your bank that pays 2.5 interest semi-annually. How much money will be in your account after 10 years? How much interest did you earn? Okay, let's put this into a real-life situation. Okay, let's put it into a say you have $9,000 there at your house, and they offer you to open an account, right? To put that money in there, they're going to pay you 2.5% interest semi-annually. So how much money will be in your account after 10 years? Okay, let's find out. So there's my formula, right? So we're going to use the other formula instead. The future value equals to PV 1 plus I to the nth power. So easier to input. I mean, this formula, the second formula is easier to input in the calculator, right? Because when you have here like division and multiplication, at times students make mistakes. So the second formula is much easier. So we're looking for the future value, right? Because we want to see how much money will be in 10 years. So that's what we're looking for. I recommend for my students to write every variable down here, right? The FV, the PV, the R, the M and T, the I, and the N. And then this way, you know what to extract from the word problem. They're going to give you everything except for one missing thing. But in this case, we're looking for the future value because it's saying how much money will be in your account after 10 years. And after 10 years, right, that's in the future. So that's why we're looking for the future value. So the 9,000 is the amount that you enter into the account right now, which is 9,000. The R is always the one with a percent symbol, which would be 2.5%. Converted to a decimal, it'll be 0.025. Right? It says compounded semi-annually. Semi-annually means 2, right? So that's why my M is equal to 2. And the T is in years, which would be 10. So T equals to 10. And the I will be R divided by M, which will give us 0.0125. And the N is M times T, which is equal to 2 times 10, which will be 20. You see now, guys, we plug everything into the calculator, and we put it in just the way we see it there. And this is my answer. So it's going to be $11,538 and 0.33509 round off to a nearest penny will give us 34 cents, right? So it'll be 11,538 and 34 cents. So after 10 years, right, that'll be your earnings. I mean, the amount that you have there. So how much interest did you earn? So the interest earned is equal to the future value minus the present value, right? So we're going to subtract the 9,000 from the 11,538 and 34 cents. So you actually made $2,538 and 34 cents, which is not bad, right? For 10 years, if you had that extra money there, right? So that's how much money of interest you're going to be getting plus your $9,000. Okay, now this is called a future value of an ordinary annuity. This is something from 5.3. Okay, it says here, at the end of each quarter, a 50-year-old woman puts $1,200 in a retirement account that pays 7.2% compounded quarterly. When she reaches 60, what will be the value in the account? And how much interest will she earn? So this requires a different formula than the previous two. And again, right, so again, there's always going to be 7 things, right? The future value, the payment, the interest rate, the M, the T, the I, and the N. So what are we looking for here? We're looking for, at the end of each quarter, a 50-year-old woman. What will be the value? It says when she reaches 60, what will be the value in the account? So we're looking for the future value. The payment that she's putting in there is $1,200. The interest rate is 7.2% compounded quarterly. So quarterly means 4, right? I'm sorry about that, right? So you convert the percent into decimal, which would be 0.072. And compounded quarterly means 4. So here for the time, right? The time, they don't give you the specific time. But if she's 50 right now, right, and she wants to reach when she reaches 60, the time will be 10. So the I will be R divided by N, which will be 0.072 divided by 4. And the N will be M times T, which will be 4 times 10, which will give us 40. So what we do is plug in the values into the formula. We use a calculator, right? So how to use the calculator. So here, guys, I'm going to show you how to use the calculator without clearing or stopping. One steady flow until you reach your answer. So I'm going to enter what's here on the numerator, parentheses 1 plus 0.018 to the 40th power minus 1 in the calculator. So when you put enter, this is what you should see. Right in black, 1.04, 1320, 138. Then you're going to hit the division symbol, right? The division key. That's what you should see. Answer, which means this answer divided by, and you're going to enter 0.018. As you do that, this is what you should see. 57.85111.879 on your screen. Right, which means right now you're going to hit the multiplication key, which is the times key. You're going to enter 1200. And this is what you should see, 69421.34255. Right, so this is money, right? So it's going to be $69,421 and 34 cents, because right for the cents, it's the second, 2 decimal places, right? So we look at 3, right? If the 2 was 5 or more here on the third column here, or the third place, then we add 1 to the 4. But since it's less than 5, it stays at 34. So the answer will be $69,421.34. Okay, now, how much money did you invest? So how much money did you actually put in out of your pocket? Right, so you had 40 payments of $1,200. So you multiply 40 times 12, gives you 48,000, right? So in other words, right, but you got much more than that. So in other words, only 48,000 came out of your pocket, and the rest was interest. So you subtract the 48,000 from the 69,421 and 34 cents. So eventually you earn $21,421.34 in interest, which is not bad at all. Okay. Okay, now this is the last one. The last one is when you want to purchase a house. This is the formula or the section from 5.4. This is present value of an ordinary annuity. Present value means that you want to borrow some money right now from the bank because you're going to purchase something big. Most of the times it's either a house or a brand new car. In this case, okay, I use the example of purchasing a house. You want to purchase a $325,000 house with a 30-year fixed rate of 3.9%. What are your monthly payments and how much interest did you end up paying? Okay, let's find out. Again, this is a little different formula. So there's like 4 different formulas for this chapter, one from each section. Eventually, there's 5 formulas because there's 2 different ones on 5.1, which is simple interest. So again, right, we're gonna have 17. So from here, guys, what are we looking for? What are the monthly payments, right? So we're looking for the payments. So this is how much you want to borrow from the bank, $325,000. So that's your present value. The R, which is the interest rate, will be the 3.9%. Converted to a decimal, it's going to give us 0.039. The M, right? Most of the times the M is going to be 12, right? Because it's monthly. Most of the times for house payments and also for payments on cars, the M is going to be 12 because you're doing monthly payments. The time here, right, is 30 years, a 30-year fixed rate. So the I will be R divided by M, so 0.039 divided by 12 will give us something like 0.00325. The M will be M times T, which will be 12 times 30, which will give us 360. So now let's plug everything into the formula, right? But in this case, we're solving for the payment. Okay, again, how to put in the calculator without leaving the calculator like a steady flow. You're going to input the numerator on the right side, which will be 1 minus parentheses 1 plus 0.00325 plus parentheses to the power of negative 360. You're going to put it that and you enter, and this is what you should see. 0.6890436,905 on the screen. Then you're going to press the division key. That's what you should see, which means the answer divided by, which means this answer divided by, and you're going to enter 0.00325 on your calculator, and then you're going to enter it. So it's going to give us 212.0134431 on the screen, which would be everything on the right side is going to be 212.0134431. And then, hey guys, without leaving the calculator, you're going to press the inverse key. What the inverse key does, right, is going to multiply the inverse of this answer times the 325. So when you press the inverse key, this is what you should see on your screen. Hey guys, everything on green, guys, is for you guys to follow and actually work it on your own to make sure that you get the right answer. So if you follow the steps here in green and it tells you what you're going to see on your calculator, it guides you to get the answer without leaving the calculator. This makes it much, much easier to do it right on your calculator. So again, after you see the inverse, right, you're going to enter 325,000 and then you enter it. It's going to give you 1,532,921,664. Rounded out to the nearest penny will give us $1,532.92. That's your payment. So how much money did you end up paying? Okay, so there were 360 payments, right? So you multiply 360 times the payments, times the monthly payments, which was, right, let's see here, $551,851.20, which is a lot of money, right? You, instead of paying the 325,000, you paid like more than $200,000 more. So how much interest did you pay? right? So we subtract the total amount of the 360 payments times the monthly payments. You subtract the price, right, or the money that you borrowed. So you end up paying the bank like a little bit over $250,000, 226,851.20. So how can we decrease this amount that you're paying extra? Okay, what you can do is actually every month, if you have extra money, put it straight to the principal. You let the bank know, or when you make your bill, that you want to put extra money that goes straight to the principal. This way, you'll be eating the principal, and eventually you end up paying a lot less than the $226,851. Okay, because that's what we did, my wife and I, when we purchased our home. Hey guys, I believe this is it. This will be your review for your exam. And again, if you have any questions, please let us know. And I hope this information was very helpful for your exam number 2.
Thank you, Mr. Azasi. I'd like to take a moment to thank you for your wonderful presentation today. You do a wonderful job, like always. And I hope you all have a good weekend. Before I let you go, I'd like to invite you to next week's sessions. Math 1314 will be going over exponential and logarithmic functions. Math 1324 will be going over systems of equations. And then, of course, at 1 p.m., at the same link, it's going to be overcoming obstacles, turning challenges into opportunities by the EPCC Mental Health Committee. So once again, thanks for attending today, and I hope you have a wonderful weekend.